Okay, so in this part we'll finally use the resize function we defined the last time. So if you remember correctly, we have defined here resize that we use here, but we do not really want to expose it that much. It's not supposed to be an external exposed API function. It's supposed to be used internally by the dictionary. And for now we haven't used it, so we're gonna do that now. So it's gonna be in the hash dict itself, and it has to be when we set an index, so when we add an element to the dictionary. So this is checking if we replace an entry. If we don't replace one, we're adding an entry to the final number. It's here that we have to check if we are going over the maximum number of entries. So so at this point the element has been added already, so we just check here, increment the number of entries, and here, so if the number of entries is more than, so times load factor, this is the constant we defined the last time, is greater than, let's say, strictly greater than the length. No, this is the other way around. If the length of if the number of buckets, so the length of the buckets is, if we have on average per bucket more than load factor, which is the number of bucket times this load factor is greater than the number of entry. No, if the number of entry is greater than this, then it means that we have more entry per bucket on average than load factor. Okay, I'm getting it right now. So if that's the case here, we call resize. So we resize the dictionary and we just return v as usual. Okay, so that was it. That was fairly easy. Now how do we test it? First, let's just check that we haven't broken anything. It should not be the case at this point. Okay, perfect. Now we'll add some tests here. Let us check first the constructor. I think we had a constructor with a capacity of some sort. Yeah, base size. We'll keep that for now. So we'll create an empty hash dict with a base size. And then we will add some elements as to go above load factor times the size. So that would be adding elements causes resize. So we are going to create hashtag def integers and strings with a base size of 10. So we initially have 10 buckets. It means that after 30 elements added, exactly 30 elements, the resize should kick in. After 31, I think. Yeah, 31. So for two, let's make steps of 10. So 2 steps of 10s, and we want to go up to, let's say, 300. Let's see, 1 steps of 10. 300, 301. I think the length of that should be the length of that is 31. Okay, perfect. I still know a bit of math. So for I in this, let's just keep it simple. D of I equals string of I. Okay. So we'll now check d dot buckets, the size of this. So first, so when we create a bucket with a base size, the length, sorry, a dictionary with a length with a base size, the length of a bucket, so the number of buckets should be this base size. And after resize has kicked in, we should have this equals to 20 because we double the size every time we hit the limit. I'll check that my load factor, yeah, load factor equals 3. Perfect. So this should now kick in. And nope. Let's zoom out a bit. Okay, attempt to access 10th element array of buckets at index 0. What are we doing? Here, source 45. Oh, yeah. Index here is supposed to be, I knew we should have refactored this because this might be a mistake we have everywhere where we're checking this. So index is 1 plus, because this can be 0 at the lowest, so we want this to be 1 at the lowest. Yeah. 1 plus. You know what do we need for this? We need the dictionary and a key, and this computes which bucket this corresponds to. So we'll add a utility function, let's say find bucket, which will take our dictionary and a key, and this will basically redo the thing we've done 1,000 times by while copy pasting and just return the corresponding bucket in the dictionary. So hash key hash, okay, yeah. And then every time, so this is 1 plus, and then we replace all the instances by find bucket of D and key. So let's refine everything. This is here. D and key. No, we don't need index anymore. Right. D key. Key. Alright, here this is tricky. We should maybe leave this as is for now. Oh, except we also have the bug where it could, oh, this is a tricky bug, because we could have the error of finding the any index equals to 0. But we haven't. It's just one unlucky mistake, or well, one lucky because we found it in our test eventually, but we made quite some videos with this off by 1 error. So this, yeah, this is fine. We'll just leave it as is here. No more. No, this is, yeah, this is fine. Here, yeah. Key. And here again. Trade white spaces. Yeah, and here we are. This should now be fine. No, this is something else. Here again. Oh yeah, no. Okay, this is the question. Okay, so we did our refactoring. So what do the tests? We can re-zoom in. Might be better. Let's rerun the test now. We don't have, yeah, oh, perfect. We don't have off by one error. So just in case, here we need this 1 plus because indices in the basic Julia array provided in base are 1 indexed, which is fairly useful most of the time. But hashing things is one of the only cases where you want to start where you actually get either 0 up to the maximum, well, up to the size -1. And the indices are 1 up to the size, so we have this 1 plus here. Okay. So this is done. So we now use resize, and this is correctly called in our small test. So we're calling resize 1. Maybe we can check that we are calling resize twice. Yeah. Let's add a new test. So we now have a length of bucket equals 20. It means if we're reaching 60 elements, we should resize again. So for in 1 to 60, so we just have to be sure not to rewrite one of the elements. Df I plus 301, so we're sure to start at the maximum of the previous i's. The string of I. We should now have resized again. So it means that no, we should have doubled the size again, so it should be 40 here. Yep. And okay, perfect. So we are resizing, and this is now all fine. So the only thing we wanted to do last time, and I never got the courage to do because this is a bit less exciting, is removing, no, not in the tests, removing base size here, because base size is basically the length of buckets here. So this is gonna break first mostly everything, and then we'll just reconstruct things bit by bit. So it's basically, yeah, we're removing redundancy because this is gonna cause us some headaches. So we just want to remove base size where it's used. Yes. So replacing this by length of the buckets. Yeah, this is stupid. Here we doubled the size itself, and then we had to keep track of the size on a second pointer. This is nonsense. We're not developing in C. Buckets, and then resize e dot base. No, we don't have it anymore. Okay, so I assume now, so if I recall correctly, we had some base size also in our test. Yes, here. Length of the buckets. I think it's the same thing we have later. Okay, I don't, oops, no. Yeah, no. Yep, typo here, okay. Let's see, we've probably forgotten something, but let's see. Oh no, perfect. Okay, so we removed base size, so this is all fine. This is a refactoring we have wanted to do for a bit. Wanted to do, sorry. And finally, one thing I wanted to do is add the possibility, instead of resize, to add a function which would be add capacity. So base resize is basically add capacity, which is equal to the current capacity. But for some reasons, you might want at some point to know exactly, I'm gonna resize my dictionary twice because I know exactly the number of entries I'm about to add. So in that case, I would prefer to resize myself with a given capacity beforehand, rather than wait for the dictionary itself to resize several times, which is not ideal. Of course, the best thing to do in that case would be to allocate the proper size, the proper number of buckets initially, but you might not know it at the construction of the dictionary, but later on. So the function is going to be roughly the same, except not going to be a base function this time. It's going to be capacity. Yeah, do we want it like this? We could also just use resize and add a second. Yeah, maybe we'll do that. We just use multiple dispatch here to have base resize with d and a capacity to be an integer. We'll also document this with, let's relax this. This only needs to be an integer, which is the super type of int, but also contains the other integer types like uint 8, uint 16, int 16, and so on. So the function we're documenting is this one with integer, and what we want is so we're resizing, resize a hash dict by adding a given capacity. There's no op becomes a no op, so no operation if capacity is smaller or equal to 0. Okay, so if capacity smaller or equal to 0, we just return only the dictionary itself. Otherwise, so we resize this. So we resize, instead of 2L here, this will be L plus capacity. Okay. Or new size. index in +1 to new size. So for any of the new buckets, we initialize the bucket properly. So for KV in D, this does not need anything else, and this is fine. Okay. Okay. This looks fairly good. Let's get back. Did we break any tests first thing? Nope, all good. It would have been surprising, except if we had some syntax error or anything like this. Okay, let's try to add some tests. So at the end, for example, let's say here we'll just copy the same test roughly. Resizing with capacity avoids later resize or automatic or allocating capacity, so avoids automatic resize. So again, we create our dict with a base size of 10. We'll still test that we correctly get to a number of buckets of 20, but then we'll do resize of D with let's say 10 more, so it will reach 30, which means that now if we have 30, adding this new 60, so we have 30, this means we should not oversize before 90 elements, and so this means that this should not resize, so it means we're still at 20 here. No, sorry. We're now at 30, we said, and we are still at 30 after here. Okay. And, oh, no. Yeah, too easy. 60 equals 30. Did we... oh, wait, right. So number of brackets, so we resize with 10 here. So where did it fail exactly? We're 149. So that's this one which failed. Oh wait, no. We add 30 elements here. And then we had 60 new. So yeah, we need more than that. I think with 15, this should be fine. No, 15. Still not. Oh, wait. 35. Am I just terrible at arithmetic? I think so. So we start at 10. We're now at 20. Oh, right. No, we did add. So no. We are now at 35. Still now, this is now failing at. Of course, no. I should have, of course, created variables for this to make sense of the arithmetic. Okay, but now it passes. So we're resizing with the capacity here to make sure that we have enough capacity to hold the next 60 elements. While it would have failed without it, but now it's fine, so it's passing. Okay, we'll stop here from now. Let's just commit these new features. So this is resize with capacity and refactored or field base size.